Welcome to the video for objective 6x or 6f. I will be able to find the balance point of a set of data and use it to write an equation for the line of best fit. All right, so what is a line of best fit? This is a straight line that represents the data on a scatter plot, and it's also known as a trend line. So we'll come back and fill in this part about the balance point in just a moment, but let's look down at this graph. Which equation best represents the data in the graph? Well, all these are in slope-intercept form, so I'm going to go ahead and plot them on here and see which one represents it. So we're definitely seeing a negative correlation here, and there is a correlation. So there could be a line that we're going to draw that represents this set of data. So let's try to plot this one first. Our y-intercept's at 0.7, so we're going to say right about there. And then we have a negative slope of 1 over 1. So 1 over 1. 1 over 1. Like that. Okay, let's go and look at the second one. Notice they all have the same y-intercept. If we're going to plot the second one, I'll do it in pink, we're going to start at the same spot, but now we have a positive slope. That's really not going to represent the data, even if I'm not even going to plot points right now. I'm just going to draw it in because I want you to see that. Even without counting off 1 over 1, that does not represent the data. So that's not going to work for us. We can also go ahead and skip this one because it also has a positive slope. And since we have a negative correlation, a line with a positive slope is not going to be the line of best fit. Lastly, we'll give this one a try. We're at negative 0.07. Oh, I said they were all the same intercepts, but I guess this one is not the same. It's at negative. So we're going to go down here. And then negative 1 over 1. So negative 1 over 1. 1 over 1. 1 over 1. I'll go ahead and draw that line in. Okay, so now that purple line is D here. And I'm going to say that the purple line's a little low to be line of best fit because if you see all these data points, they're almost all above it, whereas this green line runs pretty much right down the center with some of the dots above, some below, but they're all pretty close to it. So I'm going to go ahead and answer this question now that the line that best represents, or the equation that best represents the data, is A. Ooh, that is a horrible circle. All right. Now we're going to get into what our objective is asking. I will be able to find the balance point of a set of data and use it to write an equation. So first we're going to plot the data points and see if there is a linear trend. If there's no correlation, then we can't draw a line if we don't have a linear trend. So that's the first thing we need to check for. So we're going to go ahead and plot these points. So pause the video, plot your points, and then rejoin me once you have them all in place, and then check with what I've created. Okay, so check that your points look like my points, but I do see a linear trend here. It's definitely a positive correlation. As my x's are increasing, my y's are increasing on each of these dots. So now we're going to write the line of best fit. To do so, the first thing we need to do is find the balance point. To find that is we're going to find the average of the x coordinates. So I'm going to take, let me change colors here. I'm going to take all of these x coordinates, all these numbers here, and add them up, and then divide by 1, 2, 3, 4, 5, 6. So go ahead and do that. Add them up, I got 2. If you didn't get 2, make sure you're watching your negatives here because it's negative 3 plus a negative 1. And then I divided by 6. And so my average of the x coordinates was 0.33. You can go ahead and pause the video and do the same for these. We're just adding these up, coming up with that number, and then dividing by the number of numbers, which is 6. When I added them up, I got 5. Divide by the number of numbers, 6, and my mean for the y coordinates is 0.83. And I'm just going to leave it right there. So 0.83. Now I want to put these together in a coordinate pair. So my x is 0.33 and my y is 0.83. Let's go ahead and plot that and see what this looks like here. So 0.33 is right about there, and 0.83 is, I'm going to say, right about there. So the balance point is the point along this line that would balance out the line. Okay, so kind of just right in the middle of everything. Up to the top here, we can add in our definition, the coordinate that has an x coordinate that is the mean of all the x's of the data, and a y coordinate that is the mean of all the y's of the data. Go ahead, pause, write that down, and then rejoin me. All right, so we still have more to do here. All we've done so far is to find the balance point, and we have a couple more steps here. So let's see what they are. So next we're going to estimate the slope. We want an equation of a line. So we have our balance point, this purple guy right there, and now we need to estimate the slope. Is it a positive or negative correlation? Well, it's going uphill from left to right, so it's positive, which means that my slope is going to be positive. If it was negative, I could go ahead and put in a negative sign right here, but it is going to be positive, so we don't need to put anything, but if we just want to be clear here, I'm going to put a plus just so you can remember that it's positive. Now we're going to estimate the rise over run. So we're just kind of, let's just imagine what this might look like. I'm just going to draw some dots in here, from my balance point. Okay, so here's my balance point. If I estimate the rise, I would say we're not really going up 1 over 1. Because if I go 1 over 1, I'm really getting off here. What if I go up? Let's find a point over here that might be easier to estimate to. How about if I go up 1, 2, 3 over 1, 2, 3, 4, 5, 6, or 1, 2 over 1, 2, 3, 4. So I came up with 3, 6, which is also equal to 2 over 4, which is also equal to 1/2. So my estimation here of my rise is going to be 1, and my run is going to be 2. So my slope is going to be a positive 1/2. My last step here to create the line is put it in point slope form. And recall that that's the form where we have y minus y1 equals m times x minus x1. And the reason it's called point slope form is because the m right here is your slope, and your x1 and your y1 is the point that you have, and in this case, it's our balance point. Okay, so now let's go ahead and put that all together. So I'm just going to write the skeleton of my equation here and then put in all the pieces that I have above. So I'm going to leave the y minus, and I'm going to leave the equals, and I'm going to put in my parentheses and the x minus, and then put it all in. So I need my x coordinate. X1 is going to go right there. It's positive, but once I put in the equation, it's going to become minus, so minus 0.33. Then our y coordinate's right there. And I'm going to put that in for my y1, which is right here, so negative 0.83. And then last, our slope, which we found out right here, is a positive 1/2, which I'll put right here. All right, I now have my equation for the line of best fit, and I can graph it using exactly what I have here. I have my point and slope, and that's all you need to graph something. We've already plotted that point. There's the point. And now we just need to plot the slope. So 1 over 2. Make another dot. 1 over 2, right about there. And I'm going to go draw a nice solid line in there now. it over to the back, and what I would like you to do is go ahead and pause the video and see what you can do, see what you can come up with, and then play it again when you're ready and see if you're correct, see if you did it the right way. So give it a try, and then rejoin me once you have done exactly what it says here, which is plot the data set. Is there a linear trend to the data? If there is, then I want you to use the steps on the front that I just showed you to create the line of best fit and then graph it. Okay, so I've plotted my data, and I would definitely say there's a trend, and I'd say it's a pretty strong correlation. Just to piggyback off what we were talking about with the correlation coefficient, not that I asked this of you for this one, but I would say that R equals, and is it positive or negative? Well, it's going to be positive 0.9, I would say, because that's pretty close. All right, now you should have added these up and divided by 1, 2, 3, 4, 5, and added these up and divided by 5. The numbers I came up with for my balance point here for the x was 3, and for the y is 6.8. So my balance point would be the coordinate 3, 6.8. I'm going to go ahead and plot that right in the middle of my data here and see if it makes sense. Now, if you came up with something different and you plot it and it's not in the middle of this stuff here, then you probably did something wrong over here. So that's a good way to check it, is just to go ahead and plot it in there. So 3, 6.8 is, well, especially since I made that dot pretty big, that 3, 7, it is right there, right below it. I'll go right there. This is to estimate my slope, and my slope is going to be positive because I have a positive correlation. So my slope's going to be positive. And then I just need to kind of see my rise over run. Well, it's going to be pretty steep. I'm going to go with, let's see, 1, 2, say, oh, you know, it's just like a guesstimate right now. But let's go with 2 over 1. So up 2 over 1. And when I divide that, I get 2. So now it's just a matter of writing my equation correctly. So I'm going to put in y minus my y coordinate, which is 6.8, equals my slope, which is 2, times x minus my x coordinate, which is 3. And then my last step here is I want to plot it. I already have that point there, so I just need to count off my slope. Up 2 over 1, up 2 over 1. I'm going to put in some down here, down 2 over 1, down 2 over 1. Look, I'm right on those. And then I'm going to draw in my line. Here's my equation of my line of best fit, and there's my actually graphed line of best fit. And I'm going to say that's pretty darn close. And we'll get into how to find out if your line of best fit, how close it is, next time. But for now, give this one a try. Let's see what you can do, and then we'll check it in class. And I just want to kind of see if you've picked up on this and can create an equation and a line all by yourself. All right, thanks for watching, and I will see you in class.